Here is a simplified approach on solving moment of inertia of plane areas. Problem number 1. Find the moment of inertia of the area bounded by the parabola y squared equals for x, the x-axis, and the line x equals to 1 in the first quadrant, with respect to x-axis. First is graph the curve and the lines, and locate where they intersect at each other. At line x equals 1, it will intersect the curve at y equals positive and negative 2. Remember, we only need the area bounded at first quadrant. Tip number 1. Always use a strip parallel to the required axis of moment of inertia. For example, to solve the moment of inertia with respect to x-axis, we have to use a horizontal strip. Differential area will be x times dy. Now, draw the distance of the center of the strip from the required axis that will serve as the moment arm. Solve for the value of x in terms of y from the figure, that is x of line of x of parabola. X is equals to 1 minus y squared over 4. Tip number 2. Moment of inertia is equals to integral of differential area times the square of the moment arm. Differential is in y, so limits must be also in y. Substitute the value of x into the formula. And the answer is 1.067 units to the power of 4. Try solving the moment of inertia respect to y-axis. Problem number 2. Find the moment of inertia bounded by the curve x squared equals for y in line y equals x with respect to y-axis. Do you notice that we always start with graphing the functions? Sometimes we thought that drawing these figures takes more time, but actually it does not. It's true that it takes some time to draw, but it will help you visualize and get the correct answer faster. If you are viewing this video, and you have difficulty understanding how we draw these lines and curves, you have to review your lessons from analytic geometry. Now, we have our plane area as shown. Referring to the tip we shared earlier, if we wish to solve for the moment of inertia respect to y-axis, we have to use a vertical strip. Y, or the height of the strip, is equals to y of line minus y of parabola. Now for the moment arm, measure the distance between the center of the strip and the required axis, and that is x. Iy is equals to integral of differential area times square of moment arm, x. Limits will be from 0 to 4. Get the value of y in terms of x. Integrate using the calculator. And the answer is 12.8 units to the power of 4. Learn to not only memorize the formulas, understand the principle behind them.